Alright, so here's part 2 of chapter 2, quadratic functions, which end up giving us graphs of parabolas. Or parabolas, depending on which part of the US you grew up in. So basic parabola, y equals x squared, quadratic function. If you were to make a table for x and y, let's try -2, -1, 0, 1, and 2. If you square -2, you get 4. Square of -1 is 1, 0, 1, and 4. Making a quick graph. We get the point 0, 0. We get the point 1, 1, and -1, 1, 2, 4, and -2, 4. And so we get this U-shaped graph. Heads up and to the right forever, comes down from the left to what's called the origin. That origin point there is called the vertex. The most important point of a parabola, this vertex is 0, 0. So from that parabola we can generate any other by using transformations that we talked about in the last chapter. So I could shift this left, right, make it fatter or skinnier. So let's make a wider parabola. So to make it wider, I would multiply the outside by something like 1/2. And then maybe I want to shift it to the right, which means I would replace x with something like x minus 2. That's right, so instead of just an x squared, I have an x minus 2 squared. And then maybe I want to drop it down, let's say 1 unit. So then I could just subtract 1 on the outside. So that should be this function. And it's going to be shifted right 2 units. It's going to be vertically compressed, which will make it wider, and it's going to be right 1. Okay. So my prediction is that the graph is going to look something like this. So I'm going to go over 2 units and down 1. So that should be the new vertex. Now this parabola had a point right 1, up 1, but I'm compressing it. So it should have a point right 1, but only up 1/2. So I believe that point right there is going to be the point 3, -1/2. We'll test that in a minute. Also, from that vertex point, I used to have a point over 2, up 4. So that vertical compression should give me a point over 2. Instead of up 4, it should be up 2. So that should put me where? Right about there at 1. So I should have the point 4, 1 on this graph. All parabolas have a line of symmetry called the axis of symmetry. And you have a mirror image on the other side. So if I have this point that's right 1, up 1/2, I should have left 1 from the vertex, up 1/2 point. If I have a point that is right 2, up 2, I should have a point left 2, up 2. So there should be a point right there. So it looks like the y-intercept is the point 0, 2 for this. Oops, now I went up too high. I went up 3 instead of 2. And we would have saw that once we graphed it on the calculator. So I like to graph things by hand and the calculator, sometimes by hand first, then calculator, sometimes vice versa, depends. So here's a rough sketch of this parabola on a similar scale to the other one, and so it looks a little wider than that one does right there. Okay, let's whip out the calculator, confirm that graph. So I'm in the y equals menu. Find yourself an open line. Oops, don't blow away papers. And I'm going to enter my 1/2 times parentheses x minus 2, close parentheses, square it, and then subtract 1. I'm going to go for the standard viewing screen, so zoom option 6. If we don't like that screen, we can always change it. Alright, so check that graph out. So that is, to the best of my artistic ability, this graph down there. Not too bad. Okay, I can confirm some points by going trace here, and then I believe I have the point 2, enter, -1. I believe I have the point 4, 1. I believe I have, whoa, my notes are blowing away, crap. I believe I have the point 3, should be -1/2, -0.5. Very nice, huh? Okay. Alright, so let's see what else do we want to do here. Let's see, important points on a graph are intercepts. Now, I happen to have found the y-intercept by getting lucky. You can always find the y-intercept of any graph by plugging in x equals 0. So if I call that function f of x, then I'll be finding f of 0. F of 0 in this case is going to be 1/2 times 0 minus 2 squared minus 1. 0 minus 2 is minus 2. If you square minus 2, you get 4. Half of 4 is 2. 2 minus 1 is 1. And so here I have the point 0, 1. Pretty nice, huh? X-intercepts, let's do those in green. Little harder to find. So, am I on my page there? Barely. There we go. So x-intercepts, I have to let y equals 0 and then solve for x. So now I have 1/2 times x minus 2 squared minus 1 equals 0. And I have to solve that. Now just a note, this form that this is in for a parabola is called vertex form. Okay. Vertex form is always some number a, that guy, times parentheses x minus h, h being one of the values of the vertex, plus k, k being the y value of the vertex. So I can look at something in vertex form and say, hey, the vertex must be 2, -1. And then the number up front tells me whether it's facing up, opening down, whether it's fat or skinny, or same shape as the basic parabola. So I get a nice intuition by just looking at the vertex form equation. Then there's what's called standard form, which we'll talk about in just a minute. Vertex form is super easy to solve for. I don't square anything out here. I would just add that one to the other side. That would give me 1/2 times x minus 2 squared equals 1. So I just want to isolate x. There's only one x, which is nice. Scoot up a little. Next I would multiply both sides by 2 to get rid of that 1/2. That's going to give me x minus 2 squared equals 2. Now, to solve a square on one side, just numbers on the other, you just take the square root of both sides. Square root and square cancel. Now, they don't cancel completely. There's a little trick I'll talk more about later. But when you take the square root of a square, you adjust the other side by putting a plus or minus in. Then over here I have the right to say it's just x minus 2. Finally, I can add 2 to the other side. I prefer to write that first, then I have plus or minus square root of 2. Okay. So there are two x values. One x value is 2 minus the square root of 2. That's that guy right there. The other is 2 plus the square root of 2. That's that guy right there. So let's just check that on the calculator to see if they work. So I'm going to ask the calculator, since I already found them. I'm in trace mode, right? If you're in trace mode, you just type a number you want. So I'm going to type in 2 minus the square root of 2. Close my parentheses because I'm a good math student. Enter. Calculator says, hey, yeah, that's about 0.59, and y is 0 there. Cool. The other one should be 2 plus the square root of 2. Close parentheses. Enter. Bingo. Calculator tells me it's approximately 3.41, and y is 0 there. So I have found the x-intercepts, which are also called the zeros of a function. So this function has 2 zeros. We know them exactly That's 2 plus or minus the square root of 2, or approximately 0.59 and 3.41. Kind of neat. I can also check one more time by going to the Calculate menu, so second trace, and I can ask the calculator to find a 0 for me. Enter. Calculator says get me to the left. Alright, so let's see. That's to the left of that 0. Enter. Calculator says get to the right of that 0. Enter. Calculator says guess in between. Enter. And the calculator says 3.4142136, which is about what we knew before. Y is 0. Okay. Calculator doesn't tell me that number happens to be 2 plus the square root of 2. So just using the 0 feature of the calculator gives you an approximation, which is cool, but it does not give exact answers. So it's great for checking. And your routine with these guys is wherever possible we find exact answers and we approximate them. So on paper here, my answer could be made a little bit better by saying that this guy is approximately 0.59 and this guy is approximately 3.41. Okay, so these are what are called zeros of f of x. Okay, so if it's in vertex form, it's nice. You just add that number over, you get rid of this number by multiplying by its reciprocal or dividing by it, take the square root of both sides, get rid of the number inside, and boom, done. Real nice. Alright, let's look at that a little bit different. So I'm going to pick on that same function. Let's see, where's my paper star? There it is. So I have f of x equals 1/2 x minus 2 squared minus 1. Now let's suppose you're just in heavy-duty algebra mode and you can't help yourself about squaring that out. Well, squaring x minus 2 means to take x minus 2 times x minus 2. Distributing, you're going to get an x squared minus 2x plus 4. Adding like terms gives you x squared minus 4x plus 4. Now keep in mind, however, that all of this needs to be multiplied by 1/2, and then you need to take 1 away from it. Okay, so distributing the half through, I get 1/2 x squared minus 2x plus 2. Still got to take that 1 away. So finally, I have a different way to write f of x, which is 1/2 x squared minus 2x plus 1. This is called standard form. Standard form is cute, it's nice, it's useful. Some things it tells me. The leading coefficient tells me whether it's facing up, it's positive, so this opens up. It was negative, it'd be opening down. The 1/2 tells me it's wider than the basic parabola. And the 1 here, remember, is the y-intercept. Tells me the y-intercept is the point 0, 1. Okay, so where the other form tells me the vertex and the shape and the orientation, this one tells me the y-intercept and the shape and the orientation. If we were to find the x-intercepts here, that means we have to set y equal to 0 and then solve for x. Okay, let's do it. Switch back to green because it's a nice day. 1/2 x squared minus 2x plus 1 equals 0. We have a couple options. We can use an idea called complete the square. We could pray at factors. Probably unlikely here, especially given what we already know about the answers. Or we could use the quadratic formula. So I'm going to jump to the quadratic formula here. Quadratic formula says that if you have something that looks like ax squared plus bx plus c, and it's equal to 0, very important, then the x values that make that true look like this. Opposite of b, plus or minus the square root of b squared minus 4ac, all inside the root. Notice I put my little hook to be clear what's in and what's not. Big fraction bar covering everything over 2a. So in this case, I need a new page. A is equal to 1/2. B was -2, I believe. And C is 1. It's always a good idea to write those down to be clear to yourself. If you don't have this memorized, my hope is you do because you've seen it in a previous math course. If you don't, write it down every morning at breakfast and every night before you go to bed until you have it memorized. We need to plug in to this. So carefully doing that, I get the opposite of negative 2 plus or minus the square root of negative 2 squared minus 4 times 1/2 times 1 all over 2 times 1/2. And then clean it up carefully. It's 2 plus or minus square root. Let's see, now what do we have there? Negative 2 squared is 4. 4 times 1/2 is 2 times 1 is 2, so we have 4 minus 2 all over 2 times 1/2, which is 1. Let's just write 1, huh? So I get 2 plus or minus the square root of 2. Dividing by 1 is kind of boring, so there are my answers. Okay? So sometimes, if it's in what we call standard form here, quadratic formula is a nice way to go. If it is in vertex form, then you just unwrap things that are furthest away from the x working into closer. So you get rid of that, get rid of that, get rid of the square, finally get rid of 2, and you get an answer. I prefer vertex form if I get it. I don't always get it in the start of the problem because I can just identify the vertex by looking, and it's easy to solve for the x-intercepts. Lots of room for error, and the quadratic formula requires lots of practice. So, go practice. A couple more things I want to do an overview on, which I'll get to you soon. Bye.